In this video, we'll look at the 6 main trigonometric functions, how they come from triangles, and the special values of these functions. So there are 6 main trigonometric functions, which can be related both to triangles and then just to angles in general beyond that. So if we have a right triangle, and we mark this angle here as theta, we have the opposite side, the adjacent side, and the hypotenuse. Then we have our 6 main trigonometric functions from this. So we have sine of theta, which is opposite over hypotenuse. We have cosine, which is adjacent over hypotenuse. We have tangent, which is opposite over adjacent, which is also sine over cosine. And then we have the other 3 that are the inverses of these. So we have cosecant, which is hypotenuse over opposite, which is 1 over sine. We have secant, which is hypotenuse over adjacent, or 1 over cosine. And cotangent, which is adjacent over opposite, or 1 over tangent. There are a lot of identities based around these functions, and we'll talk about them more later. But the main one to sort of think right off the bat from the triangle definition is the Pythagorean identity, or the fact that sine squared theta plus cosine squared theta equals 1 for all theta. It doesn't matter what you put in there, that's always going to come out to 1 if you have sine squared of a thing plus cos squared of the same thing. That always equals 1. Now in terms of our special values and special angles, we can think about those here. Now for this course, everything that we do will use radians. So what are radians? The main point of radians is that if I take a circle that is of radius r, and I cut out a center arc of angle theta, then the length of this arc here is r times theta when I'm doing things in radians. So radian measure is so that that arc length is r times theta for a circle of radius r with interior angle theta. In particular, this means that for a full circle, we know the length is going to be 2 pi r, so the angle measure of a full circle is 2 pi. In degrees, this is 360 degrees, so that gives us a way to convert between degrees and radians. In particular, the measure of an angle in radians is pi over 180, it's 2 pi over 360, times the degree measure. And you can use 180 over pi to go the other way around. Now what does that mean for special angles? Well, that means that if we were to look at a table of sort of special angles, right, in degrees, you would have 0, your 30 degree, 45 degree, 60, 90, and then you could look at, say, 180, and 360 goes back to 0. In radians, what do those come out to? Well, 0 is still 0. If we look at pi over 180 times 30, that's pi over 6. For 45 degrees, we get pi over 4. For 60, we get pi over 3. 90 degrees is pi over 2. And 180 is pi. So half a circle is pi radians, a quarter circle at a 90 degree angle is pi over 2, and the other ones fill in below like this. So what does this mean? Well, if I want to look at, say, sine of theta, I know what that does for all these special angles. Sine of 0 is 0. Sine of 30 degrees, or sine of pi over 6, is 1/2. For pi over 4, I get root 2 over 2. For pi over 3, I get root 3 over 2. For 90 degrees, I get 1. 180 is back to 0. For cosine theta, they go in the reverse order. 1, root 3 over 2, root 2 over 2, 1 over 2, 0, and cosine of pi is negative 1, because that's over on the other side. You can do tangent as well, and the rest of the functions follow suit. You can also visualize this from the unit circle, because on a unit circle of radius 1, for any point, the coordinate values of that point are cosine theta, sine theta, for this angle here being theta, and you can sort of visualize how it all relates to these values here as well.